Hello there, guys. Happy Wednesday to you if you're watching this on time. Hey, just one little note. 513 is a somewhat significant day. It just so happens that 34 years ago, your favorite Mr. McSparron was born on 513. So, understandably, the expensive birthday gifts that you would have gotten me and brought to me at school, you're wondering how to get those to me, you can probably just reach out to Dr. Stanley and you can just drop them off, whether they're $100 gift cards or new electronics. You can just you can arrange with Dr. Stanley to drop those off, and he can get them to me. I promise. Okay, so this is kind of it's almost like our last lesson type video of the entire year here. This is the last objective of the geometric measurement and modeling. Now, this one is for some people it kind of comes easy. For other people, it takes a while to really wrap your head around how this looks. These questions are going to ask you something specific. They're going to ask you to create a three-dimensional object by rotating a two-dimensional object. In this case, the two-dimensional object, sorry about that, is going to be this rectangle. So it's like the last objective where we started with 3D and then we sliced it into 2D. This is starting with 2D, but now we're going to rotate it to make it into 3D. Now let me just, oh man, okay. For just a second, I gotta have a sticky note. Okay, so let me show you the way that I've done this with students before when we're just sitting in class is I'll take a 2D object like a square, and then I will put it onto something that I can rotate like a pencil. And we can imagine rotating that square around that pencil. Now, if you kind of look at it from different angles and you imagine the path that that square is traveling, it creates a 3D object. And in this case, that 3D object would be a cylinder. Now, sometimes this is really hard to visualize. So lucky us, Summit, as amazing as they are, they actually found a resource for us to watch this happen in an online simulator. We'll hide that. Okay, so let's do the one that we saw first. Okay, so this is rotating a rectangle. Now, oh, I hope this works. Yeah, there we go. Perfect. Now, notice we've got a rectangle, and right now it's just two dimensions. Now, I can spin it around and I can view it from different angles. Okay, but ultimately what I want to do is I'm going to rotate that rectangle around this line right here. So imagine that my pencil was connected to that, and I'm going to take and rotate. Now, we rotated that rectangle all the way around that one line. And what you see now is that I have a cylinder. By rotating, I created a three-dimensional object, and that 3D object is a cylinder. If I unrotate it, I can see, whoop, that it goes back to being a rectangle. So let's actually think about that. Let's make a little cheat sheet over here. So rectangles usually rotate to make cylinders. All right, let's go check out that triangle. Now let's triangle. I record and also use the internet at the same time. It struggles sometimes. All right. So you see I have a triangle. I'm going to go ahead and I'm going to rotate my triangle. See, so it's traveling all the way around. And when we rotate a triangle along, well, especially it's almost always right triangles that we rotate. Notice what shape it makes now. That, friends, is a cone. Now, what I want you to notice is that doing rotations tends to create things that have circular bases because a rotation is a circle. So think about a cylinder. A cylinder has a circular base. A cone has a circular base. What type of object it is depends on the cross section, which is what we start off with, okay? So let's go write that in here now. Triangles, when we rotate them, tend to make cones. All right, you can do a couple more here. Let's see, what else do they have for us? Definitely want to rotate circles. All right, so watch what happens when I rotate this circle. It goes around and around and around. This, I kind of like to think of it like one of those paper party decorations that you hang up. Oh, come on, guys. This one's kind of hard to see, isn't it? The colors of this one make it hard to see. But what you should notice there is that when you rotate circles, and this is always the case for circles, when you rotate circles, they make spheres. Sometimes sometimes they will rotate hemispheres, or we'll call it a half circle, or what do they call it, a semicircle? We'll call it a half circle, and nobody will even be mad at us. Half circle could make a sphere or a hemisphere. Depending on, so if you were to take a half circle like this and rotate it around, hi Jake. If you rotated your half circle around that line and you went all the way around that way, you would make a sphere. If you took that same half circle and rotated it around that line and it went around there, it would just make a hemisphere. It wouldn't go all the way around. Now, let me try and illustrate for you. Now that you've seen some examples of that, let me try and illustrate this one for you, okay? So this wants us to rotate the rectangle around the line, x equals 1. So the first thing we want to do is let's draw in x equals 1. Remember that x equals lines will always be vertical, up and down, and y equals lines will always be across. So like this line here, that line would be y equals 1, okay? So sometimes people get tripped up because they think, oh, x equals 1, the x-axis is like that, so my x equals 1 must also be like that. That's not true. Our x equals lines are the opposite of the x-axis, and our y equals lines are opposite of the y-axis. All right, so I'm going to get rid of that y equals 1. I'm going to leave my x equals 1. Now, I'm going to attempt to do a kind of a fun drawing for you here. Let's see if I can pull it off, okay? So I'm going to draw my own coordinate grid, but I'm going to do it in 3 dimensions, okay? So now I'm going to have y, and I'm going to have x, and you're going to be like, whoa, McSparron, whoa, 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 whoa. That x is crooked. It's just because I'm making it 3D, and I'm going to make it a little bit tilted so we can see. So I have a third dimension now, which is depth, and depth is the z-axis. All right, now let's figure out where that rectangle goes. So my rectangle is going to be 4 by 2. So I'm going to go 1, 2, 3, 4. And then I'm going to go 1, 2. And I'm going to draw, let's draw my rectangle in, we'll just draw it in pencil. So notice how I still have a 4 by 2 rectangle, but now it is on my 3-dimensional grid. Now, this is important because remember that we have x equals 1 is where the rotation is. So x equals 1 actually goes that's x equals 1. So when I go to rotate around that, remember, it's just like saying that x equals 1 is my pencil, and I'm going to rotate around. Oh, wait, where's my stickiness? It's not very sticky. It's not good. I'm going to rotate around x equals 1. All right, so let's see if I can draw that. So first thing we want to notice is that from the center to the edge, that is 3 units. So imagine rotating that around that x equals 1. So I'm going to go this direction, and I'm going to end up with 3 units that way. Okay, so I'll go there. And then it's going to go 1, 2, 3. 1, 2, 3 units that way. So it's going to go there. Then it'll come all the way around until it goes 1, 2, 3 units that way. So it's going to go there and then all the way back around. Okay. So the top edge of my circle has gone around like that. Now, I always have the other edge of my rectangle, which is 2 units down. 2 units down, 2 units down. So think about what shape I end up with once I do the whole thing. I don't know how to shade it so that we can see it really well, but here, maybe I can I color it in with what color should I use? Color it in with purple. All right, so I end up with my circular base, my height, and that is like a disc, or you could think of it as a cylinder. All right, so my cylinder has a radius of 3 and a height of 2 because my original square had a radius of 3 and a height of 2. So that means that that is my answer. Hopefully that makes sense, guys. I know that this is hard to visualize. Try sketching, try holding objects up. If it's a triangle, guys, cut a triangle out of a sticky note, tape it to something, and spin it and see what it looks like. Okay. Follow my cheat sheet. You're welcome to use notes. If you have questions, please, please, please email or sign up for a Zoom. That's all I've got for you. Enjoy. Good luck.